Four regular hexagons surround the square with side length 1, each one sharing an edge with the square, as shown in the figure below. The area of the resulting 12-sided outer convex polygon can be written as m root n plus p, where m, n, and p are integers, and n is not divisible by the square of any prime. What is m plus n plus p? I have a larger figure in the next page, so let me just scroll down and let me use this big figure here. First of all, I would like to call this shape a flower because it reminds me of a beautiful flower, or it looks like a beautiful flower. Right. The first observation is, let's look at those two red points, and let's draw the line connecting those two red points. Like, observe that this yellow triangle is indeed 30, 31, 20, right? Isosceles triangle. Okay. So then, since one angle of regular hexagon is 120, this angle has to be 90 degrees. Right. But red line makes 90-degree angle with one side, with the horizontal side of the square. So is one side of the other side of the square. That means this red line and one side of the square should overlap. Or in other words, if I extend the side of the square, it has to pass through this red point here. Okay. Now, how about if I get rid of this red line and I can just safely say that when I extend one side of square, it has to pass through one corner of the hexagon, and these are vertical, so this side is parallel to this side here and also is parallel to this side here. Right, so when I do the same extension from this corner, I'm going to obtain a similar result. So this side is parallel to the horizontal side of the square as well as the horizontal side of the hexagons, right? This is nice. And then since this is 90 degrees, this has to be 90 degrees, right? So let's calculate some side lengths. So in the yellow triangle, yellow triangle is an isosceles triangle with sides 1, 1, and angle in between is 120. So the opposite side have to be √3. Okay, and when we subtract off the side of the square, the remaining part is √3 minus 1. When we do the same thing from the other side, this side also has to be √3 minus 1. Okay, and when we extend the outer lines, we are going to get a little square on the left corner. Why? Because this is indeed a parallelogram, and one angle is 90 degrees and two sides are equal to two adjacent sides are equal to each other. So that this shape has to be a square. Okay, and then what I can do is I can just extend all these lines, all the outer lines of the flower, and from symmetry, I'm gonna get little squares on the corners, but this big shape is also going to be a big square. Okay, so this is a big square. Let's call it a big square. And finally, when I just draw this line here, I'm going to first observe that the red triangle and the yellow triangle, or maybe I should use a slightly different color, and the blue triangle here are congruent, okay? And then I am going to find the area of the flower in the following way. So the area of the flower is equals area of the big square minus 8 times the area of the triangle. This is due to symmetry. Since I'm going to have, I have 1, 2 triangles here, and I'm going to have 2 here, 2 here, 2 here. All in all, I'm going to have 8 triangles. And then I need to subtract 8 copies of the area of each triangle. Okay, so first let's show that blue and red triangles are congruent, and second, let's calculate the area of each triangle, right? So now, due to symmetry, I can safely say that this side equals to this side, right? So these light green sides are equal to each other. Moreover, I already know that this side equals to this side, since both of them are the sides of squares. Yes. So the blue triangle and the red triangle are congruent since they have the same side lengths. Due to side congruency, those two triangles are congruent, so they are congruent. That's what we wanted to prove. Moreover, then these angles, so should be 45 to 45. And we already know that this angle is 60, so is this angle. So let's look at the red triangle and let's calculate the area here. How about if I just draw another shape here and then use this shape to calculate the area? So this angle is 60, this angle is 45. And I know that the base is √3 minus 1. Right. So let's drop a perpendicular from this point to the opposite corner, and let's call this side a √3. So this green triangle is 30, 60, 90 right triangle. So this side here should be A. And this yellow triangle here is 45, 90, 45 isosceles right triangle. So this part should be A √3. So when we write down the base in two ways, I can find A. So the base is A, parentheses √3 plus 1 equals √3 minus 1. Let's multiply both sides by √3 minus 1 and use difference of squares to get 2A equals √3 minus 1 quantity squared. And this is 4 minus 2 √3. So A is 2 minus √3. Okay, and then let's find the area of the triangle using whatever we found here. So the area of the triangle is 1/2 times height times base. Height is A √3 times the base is √3 minus 1. Okay, so this is 1/2 times, let's substitute 2 minus √3 for A, and let's multiply the remaining 2, and they multiply to 3 minus √3. And then this is 1/2 times 2 times 6 plus 3 is 9 minus 5 √3. Okay, and then next, let's calculate the area of the big square. So for that, I need to calculate one side. I know that this is √3 minus 1, and this part is 1, and this part is √3 minus 1. So the area of big square is big square is just 2 copies of √3 minus 1 plus 1 quantity squared. So the area of the flower is the area of the square. So inside is indeed 2 root 3 minus 1 squared minus 8 copies of area of the triangle. It is 1/2 times 9 minus root 5. 9 minus 5 root 3. Okay, let's calculate this. So the square term is 13 minus 4 root 3 minus 4 times 9 minus 5 root 3. And this is 13 minus 4 root 3 minus 36 plus 20 root 3. And this is 16 root 3 minus 23. And this is M, this is N, and this is P. So P is negative 23. We have to be a little bit careful when writing P. So M and M plus N plus P equals 16 plus 3 minus 23, and this is negative 4. So negative 4 is the correct answer. You go back and mark the correct answer, B.